Here's section 4.3, number 13. Um, find the area of the shaded region here. The trick to doing this one, there's two tricks. One of them is, well, one of the issues is that I'm doing the book out of order, and so sometimes they expect that you already know the law of sines or cosines, which we don't. But that's all right, we're going to be able to do it anyway. So if I draw in the radii out to the points where those line segments meet the circle, each of those radii has length 3. Okay? And so then what we want for the area is the area of this sector over here, and the area plus the area of those two triangles. Sorry, I'm hesitating for a moment because I got in order to do the angle of the sector, I need to know. So the area of the sector, I need to know that angle. I'm trying to can I figure that angle out? But I think we have enough information here. Again, the book I think is probably assuming you know the law of cosines, but we're going to get away without using the law of cosines, because what I'm going to do is I'm going to drop a perpendicular right down to here. I'm going to drop a perpendicular right down to there. Okay. Because this is 3 and 3, this splits that edge up into 2 equal pieces. So this is a 2.5 and a 2.5. Okay. Likewise, this 4 gets broken into a 2 and a 2. So there's a lot of stuff that I can do now. I can use Pythagoras to find this height, because I've got a 3 and a 2 and I get that. I can use Pythagoras to find this height, because I've got a 3 and a 2.5, so I can figure out what that is. Once I have those heights, you know, 1/2 the base times the height is the area of this triangle over here. 1/2 this base times this height is the area of this triangle. But also, once I have this, I can do, for instance, I can find this angle, because I know that the sine of that angle is 2.5 over 3. So I can use my calculator and say this angle, which I'm going to call theta, is the inverse sine of 2.5 over 3. Right? So that I can calculate that angle in there. Once I've got that angle, that's the same as this one. I can do a similar calculation with the inverse sine of 2 over 3. And figure out what this angle is. So if I know what this angle is, and this angle is, and this angle is, and this angle is, then I can subtract from 2 pi, because it's 2 pi all the way around, so subtract all those angles, and then you get this angle there. If I know the angle and I know the radius, then I can find the area. I was going to say I was going to find the arc length, but what I'm looking for is the area, right? Because the area is 1/2 r squared theta, I think. Yeah. So, well, not this theta, but so the idea is to break it up into smaller pieces that we can work with. And if we knew the law of cosines, which we will eventually, we can go directly from knowing these 3 side lengths to knowing this angle, and then knowing these 3 side lengths to knowing this angle. But since we don't know the law of cosines yet, we can still draw, drop that perpendicular, get a right triangle, and then we can use the information we already know to get that. Now, I haven't actually solved it. I can if you want, but maybe that'll get you going in a direction to be able to solve that.